Okay, hi everyone. Welcome to Thursday. Sorry that I'm not able to be here today. It's the K-8 schools have a half day, and I had to go and be a mom. So if you could please pick up a new notes packet. We're starting our next unit. If you were absent for the test yesterday, just see me tomorrow, and we'll come up with a time that you can take the test on atmosphere. Today we are starting our weather and climate unit. Oddly, we're going to start with climate first and then kind of learn the rules of climate, and we'll be able to look back at them over and over and over again during the entire unit because they're kind of this foundational aspect of science. And so today's notes are on something called climate factors. You can see all 6 factors are listed in your diagram 1 on your notes, so that's kind of nice to have that reference there. And the essential question is, how do you determine the climate of an area? And so we're going to walk through the different climate factors and just kind of examine how they help guide us to understanding the climates of different regions. So here we go. The first thing is to figure out what is climate. So climate is an average temperature and an average rainfall. Or snowfall, so just precipitation in general. So climate gives us the ability to kind of summarize what a region of the world is going to be experiencing. There's a pretty obvious difference between temperature and climate. Oh, I'm sorry, not temperature, I'm sorry, weather and climate. Weather is very temporary, so it's just for a short period of time over a small geographic area, and it changes very fast. And so weather is what, we hear on the news or on the radio or you see on the internet. Those are all weather reports, temporary, small area, and they change rapidly. Climate is pretty much the opposite in every single way. So it's long term. You need at least 100 years of data to be able to estimate the climate of an area. It refers to large geographic areas, like you would refer to the entire East Coast or West Coast when you're talking about climate. And typically it's very slow to change. You're not going to see those averages altered much in any really time span. So weather is temporary and climate is very long term. These are the 6 climate factors that we're going to go over. Some of them are a little easier to understand than others. But when looking at a region, you can apply all 6 climate factors to that region and kind of get a pretty good picture of what it's like there climate-wise. So the first one is pretty easy. The first climate factor is called latitude. So think of these factors kind of as rules that guide climate. So latitude is how far you are from the equator. Obviously, if a region is right on the equator, they're going to get more direct sunlight. So when I taught 7th grade, I'd always have these kids do an activity. I'd give them graph paper and a flashlight, and have them shine the flashlight straight down onto the graph paper. I was like, okay, kids, trace your circle and count how many squares there are. And they'd be like, oh, wow, this is so fun. There's 15 squares on the graph paper. And I said, okay, kids, now tilt the flashlight on an angle, and now they should have more of an oval shape. And I was like, okay, now count the squares. And they would all be so amazed because now there'd be like 45 squares or something. You'd have way more squares when it's on an angle. So this is an example of direct and indirect sunlight. When the sun is hitting the equator, it's getting the same amount of energy in a very concentrated, small, tiny spot of 15 squares. That's just made up numbers, by the way. When you put it at an angle, it's the same amount of energy. It's that same flashlight spread out over a larger region. So that's called indirect sunlight. So the farther you get from the equator, the more indirect sunlight you get, and therefore the cooler the climate's going to be. So this is directly related to the temperature of a region. This has nothing to do with the precipitation. Here's a cool map that shows you near the equator, it's warm, and further from the equator, it is not. The second climate factor is global winds. Global winds, we kind of already covered when we covered atmosphere, is determined by latitude. So if I was to give you a region, you would first ask yourself, well, wait, Ms. Price, what's the latitude of that place? Oh gosh, this is what happens when I record things at night. Sorry, not latitude. Wait, Ms. Price, what global wind are they in? And so you would want to know, are they coming from the easterlies or the westerlies? So that would determine whether they're going to get their weather from the east or the west. So you'd want to look to the east and the west of that place and say, hey, is this weather coming from the ocean, or is this weather going to be coming from, dry land? So global winds will determine in which direction a region would get its weather from, and therefore kind of those climates. We've kind of already covered this, that tropical regions have more rising air, warm rising air, and therefore get more rain, and that colder regions have more sinking air and therefore have less rain. And so that's why I told you the North and South Pole are very, very sunny and very, very dry, because they have all of that sinking air. This is redundant. We already covered the Coriolis effect and how that causes the winds to curve to the right in the northern hemisphere and to the left in the southern hemisphere. If you want to jot it down, that's fine. But this is something we covered with atmosphere. And so to summarize, global winds simply determines whether regions' weather will come from the east or the west, depending on what latitude they are at. Topography is another one. This is just like orographic lifting. And so mountains, the presence of mountains will create kind of a wet and a dry side. Especially, you're going to need an ocean for this. And so I'm just going to skip to the picture because it's way easier for me to explain from the picture. So we went over this when we covered types of lifting. We did advective cooling and convergent cooling and orographic lifting, and this is the same exact thing. Now we're just calling it topography because there is a mountain. Now be careful when you're doing your work today, because if you just Google topography, it's going to tell you what a topographic map is, and you're going to do horrible on that part of your assignment. The climate factor of topography means that there's a mountain, and over here there's an ocean. And so we're going to assume that this region is between 30 and 60 degrees and it's in the westerlies. And so we're going to assume that the prevailing wind systems are coming from the west of this picture. If that was not the case and it was coming from the easterlies, the mountain really wouldn't matter. So what happens is you have this weather coming from the west. It's nice, moist air because it was over the ocean. It gets pushed up the side of the ocean, the side of the mountain, like a ramp, and that air is going to cool and condense and just rain buckets on what's called, conveniently, the wet side of the mountain. Now, in this case, let's talk about Seattle. Seattle's over here, or better yet, Portland. Portland's right over here. On the eastern side of the Cascades, you have a little town called Bend. My brother and sister-in-law used to live there. On this side of the mountain, they get lots of sunshine because on this side, that same air mass that just traveled over the mountain is now all dried out. And so they get mostly sunny days. These two places might be at the same latitude. They might be at the same elevation, but because of where they are on the mountains, that's going to mean that Portland's going to have a lot of rain, a lot of clouds, but Bend, not so much. And so a mountain plus an ocean creates the factor of topography. Elevation is the next climate factor, and this is another mountain-related one. This has to do with how high you are above sea level. So I always use this picture. I'll go back to that slide, don't worry. Again, when I taught middle school, I would explain, I'm below sea level. I'm standing right at sea level. I'm above sea level. So the further you get from sea level, the thinner the air is. There is literally less air and therefore less molecules that can hold on to the heat. So as you travel north towards Flagstaff, the temperature is going to decrease simply because there is less air in Flagstaff. They get a very similar amount of radiation. We're at very similar latitudes. There's no, major ocean or anything between here and there. The big difference is simply elevation. Because it's higher, there is less air available to hold the heat. Here's another picture showing that these regions might be at similar latitudes, but as you travel up in elevation, you go from a deciduous forest to an evergreen forest. Evergreens don't need as much as warm. That's why you have pine trees and things in the north. And then you get into the tundra. You don't have any trees there. You just have really, really resilient grasses. And so as you travel upwards in elevation, this is not the same as latitude, upwards in elevation, you're going to get colder and colder because there are literally less air molecules to hold the heat. The next climate factor is a little bit confusing, so hear me out on this one. It's called proximity to water. So this is going to affect both the precipitation as well as the temperature of a region. It's going to make places much wetter along the water than compared to inland areas. So let's just talk about that. Obviously, if a region is by a major body of water, there'll be more evaporation and more moisture that can reign there. That's simple. The other thing that it does is what I call it temper. It tempers their climate, or it kind of regulates the climate. It creates a very small range of temperatures. And so if a place is by an ocean, it has a very small range of yearly temperatures. And here's a more specific example. So let's take San Diego. That's not a, oh, no, I got that. Where's that? I can't even read the map. Let's call that Los Angeles. That's not San Diego. We're going to call it Los Angeles. And let's go Oklahoma City. Here we go. So Los Angeles is about the same latitude as Oklahoma City. But Los Angeles, yes, it's going to have more moisture because it's closer to the water, but it's going to have a much smaller range of temperatures. So their coldest day of the year might be 55. I'm just making this up, but I bet it's close. And their warmest day of the year is probably about 95. They probably have about a 40-degree or so difference from their coldest day to their warmest day. Now, Oklahoma City, they are very far from an ocean. So let me go back to Los Angeles. The reason for this is because it's very close to the ocean. Now, the ocean temperature does not change much. It's hard to change the ocean more than 1 or 2 degrees. I'm going to have to pause this for a moment. Hold. So an ocean doesn't change its temperature very easily. So if you're in Los Angeles, the air that you're going to be getting from the westerlies is going to be about the same temperature and have about the same moisture all year round. So because of the change in seasons, there'll be a variation, but not much. Now over here in Oklahoma City, I say that somewhere inland like this, they kind of fall victim. They're kind of victims to all of the different air masses that are coming in. So you have air coming from the west. You're going to have some cold air coming out from Canada. Every once in a while, you have some air popping up from the Gulf. Maybe you got some weird cyclones coming in from up here, and they just get annihilated with all sorts of weather. So Oklahoma City is going to have a huge range of temperature. Their coldest day is going to be -5, and their warmest day is going to be 105. So being close to a body of water tempers the climate. It causes it not to change very much. And that's a huge role in terms of climate factors. So close to a body of water means it would have a small range of temperatures and more precipitation. Far from a body of water means you're going to have a very large range of temperatures and you're going to have a very low amount of precipitation. The last climate factor is pretty straightforward. It's ocean currents. This is really, really simple. If a region is by cold ocean currents, it's going to have cooler climate. And if it's by warm ocean currents, it's going to have a warmer climate. Now, this is going to play a role. This kind of depends on things like global winds and latitude. But for the most part, the warm or cool water will cause an overall warming or cooling effect to the climate of that region. There is a picture in your notes packet. I think it's the very, very last page of all the different ocean currents. I don't expect you to know the names of them because we actually don't spend any time in earth science and oceanography, which is kind of odd, but just the way it is. So whenever I ask you questions about the currents, I'll give you a map like this. It shows, so like let's take an example of, look at the western part of Africa here. They're directly next to a very warm ocean current, but now the eastern side of Australia is right next to a colder ocean current. And so when we are looking at these regions, we want to keep in mind, oh, look, here's this little nugget of Eastern Africa that is right next to a cool ocean current, as well as being in the trade winds there. So there's a lot to take in mind. These are just the 6 main climate factors, and we'll go over them pretty much every day for the next couple of weeks, so you should get a really good feel for them. Here's just another cool picture showing the ocean currents from kind of a 3D side, which is neat. So put all these factors together and you get the overall climate regions. And so taking into consideration all 6 factors, you can really estimate kind of what kind of climate a place is going to have. I was going to do a kind of a practice round, but we're just going to walk through these questions and kind of review the different factors. Sorry I'm not there to play the game, do the coupons and stuff. Number 1 says, which climate factor best describes this picture? So this picture is kind of tricky because it's just a mountain. And so you could pick elevation. You could also pick topography, even though you can't actually see that there's an ocean over here to the side. Number 2 says, which climate factor best describes this picture? Well, I just talked about this one. It's showing Africa that has a cool current along its southeastern coast. And so that would be the climate factor of ocean currents. Which climate factor is caused by the fact that the gravity holds air molecules close to the ground? That would be close to the ground, elevation. And so remember, as you go up in elevation, that means the air is actually going to be thinner and less able to hold heat. Which climate factor causes us to get our weather from the west 99% of the time? Well, hopefully that's the no-brainer, global winds. Global winds determines in which direction a region's weather will come from. Oh, I love this question. Which location, A or B, would have the more stable climate? So in other words, a smaller range. Think about it. Maybe tell the person next to you. In this case, B is going to have the smaller range or a more stable climate. Remember, proximity to water tells us that because B is close to the ocean, it's pretty much going to take on the characteristics of the ocean, which rarely ever change. And so B will have a more stable climate than A. A is in the middle of a continent, and it's going to be victimized by all of the air masses that are coming in from all the other directions. Which climate factor causes the climate to be very warm on average near the equator and very cold near the poles on average? That's going to be the first one, latitude. How far are you from the equator? Ooh, this is another good one. Number 7, which side of the mountains would get more rain, the east or the west? So we're referring to the Cascade Mountain Range here. I gave you examples of Portland and Bend over here, slightly different latitudes, but close. Which side would get more rain? Definitely the west side. And then down here is number 8. Which factor tells you that? The factor that determines which side of a mountain range will get more rain is topography. Remember, on your assignment today, don't Google topography, look in your notes. Number 9, which climate factor explains why the temperature decreases as you travel north towards Flagstaff? That one's easy, elevation. Try not to get elevation and latitude confused, because a lot of people do get those confused. Number 10, which climate factor best describes this picture? Well, another no-brainer, that's describing your global winds. So take some time to fill out your questions and write a summary for your notes. The sub, if you could, hand out the worksheet that I left. On the worksheet, you are going to be kind of breaking down the 6 climate factors into a drawing and an explanation, and then just with citations from the notes of the book, and then kind of explaining the science behind it. And so a lot of students struggle between these two, and don't make fun of my picture. I drew it on my laptop with a mouse, and that's what I got for latitude. It's horrible, I know. The explanation can just come from your notes or the textbook. That's what you'll be citing, your class notes or the textbook and a page number. The science part is tell me how it works. So, for example, latitude was the indirect sunlight thing. Then in the science, you're going to put this in your words. So these will be your words. Not the books. That's what the first little box is for. And so every climate factor, you need to break down what it means. Why is it warmer in one spot? Why is it drier in another spot? That's what you'll be putting in this box down here. On the back of your paper, I apologize, I added a question in reference to the 3 climate factors that are affecting Arizona the most. I asked for 3, but I put 4 lines, so that's one mistake. The other mistake is there's a bunch of grammar errors in it, so I apologize for not proofreading my own stuff. This worksheet will be due when you walk in the door tomorrow, so go back through the notes and look over all 6 factors. You'll have a keynote assignment that we're doing something very similarly with tomorrow, so the more you understand them and the more time you spend on this assignment, the better you will do on the keynote that we'll work on in class Friday. Hopefully I'm here tomorrow, but until then, happy Valentine's Day. Get this done so you don't have homework tonight. See you tomorrow.